Hey Technostuds, let's talk about IPv6 address types next. In this video, we're going to start out by talking about the different address types, which are going to be Unicast, Multicast, and Anycast. And then we're going to get into more details on each one of those. I have a whole video that I'm planning for Multicast as well that is coming up, but we'll get into some of the basics of each of these types. And then we will finish it off by talking about some other special addresses. In a prior video, we talked about IPv6 addresses and how it does not have broadcasts. What it does have is Unicast, Multicast, and Anycast. Unicast being from one device to one device, one-to-one. Multicast being from one device to multiple devices, one-to-many. And Anycast being from one device to one of potentially many devices. So an example of an Anycast message, if an Anycast message was sent out and it was destined to a particular address and multiple devices had that same address, that same Anycast address, it would be the first device or the closest device that would respond to that Anycast message, and the other devices would not need to do that. So Anycast is a one-to-one, but it's a one-to-one out of many different options. In a prior video, we also talked about these Unicast messages having multiple types of Unicast message. One of them is a link local address, one that can communicate on your local area network. We also talked about a unique local address, and a unique local address communicates on your private LAN, or private network, I should say. So it can extend beyond the boundaries of just a subnet, but it doesn't expand beyond the boundaries of what is owned equipment. It doesn't get routed on the internet. And then we have the global Unicast address. And the global Unicast address can go out on the internet because it's globally unique. It's a global Unicast address. So let's get a little more depth into link local addresses. If you have a device and it has a network interface on a network that is enabled with IP version 6, then it does get a link local address. Every interface that is capable of doing IP version 6 must have a link local address. Link local addresses are integrated into the core of how IP version 6 works and communicates. So we'll be talking more about how come that is the case in future videos, but just know for now that IP version 6 requires this link local address. It is automatically generated. Because it's required, it will automatically generate it, and it will be a unique address that is on the networks, which means that if it's trying to create this, there are several ways that it can create this, but it does need to be unique and on that local network. It cannot be routed. So when you have a link local address, it will not go beyond the boundaries of your router. So it stays local. It's local communication only. And it's used for things like next hops. So if you're talking about routers and they're communicating, a lot of times they just use link local addresses to communicate back and forth. And then it also can be for neighbor discovery. So neighbor discovery is it does actually quite a few things. Neighbor discovery is associated, the neighbor discovery protocol is associated with the IP version 6 protocol. So neighbor discovery can be used for things like discovering where is the default gateway and how to get out of the network. And then it also can be used to discover things like the MAC address of other machines. So neighbor discovery does a few things for us, and we'll get into more specifics on that. So how do your devices generate a link local address? Well, there's a couple different ways that it can generate it. So if you have a machine, you plug it into the network, it has IP version 6 enabled on it, it does need a link local address. It's pretty critical to how IP version 6 operates. So there's a couple different ways to come up with a link local address. This machine will either randomly generate a IP address for this, and when it's randomly generating, the first 64 digits is specified, so that's going to remain the same, but it's randomly generating the last 64 bits of this address. So it's randomly generating it, or it uses EUI-64, which is a way of taking the MAC address and then making an address out of the MAC address of it. So if it's a MAC address, it's pretty much almost guaranteed to be unique on your network, right? Because the MAC address, it should be a unique to that interface. It's a burned-in address. It's unique in the world. MAC addresses are supposed to be that way. They're not always that way, but it's supposed to be that way. So the idea, if you're using EUI-64, is that you're going to get a unique address with that. Even with the randomly generated, though, you run the risk of accidentally choosing the same IP address that some other device on the network has, and it needs to be unique. So it goes through a process to double check it. And so we'll talk about those processes of checking this, but just know at this point, there's two ways that your device gets a link local address, and that is it either randomly generates it or it uses a process called EUI-64 to generate an IP address, and it uses the MAC address to generate that. All right, so let's take a look at the link local address range, what range will be assigned to your computer. And when you look at this, you'll see that I've got a table, and it's got a bunch of rows to it. That's because we're going to expand upon this and fill this in this video. But right now, I'm just showing you that the link local address is going to start with an FE80 : and the first 64 bits are already specified, which means it gives you a range from FE80 : which means all zeros at the end of that, to FE8 : FFFF, 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 FFFF. That's the last 64 bits are all ones in that case right there. So we'll randomly choose a number in between that. So that is the link local address range. Then you have that global unicast address. The global unicast address is globally unique. So if you have a globally unique address or a global unicast address that's on your machine, there is no other device in the world that has that same global unicast address. That allows you to be routed to the outside world and be able to get to other devices, which seems a little strange that this is an address that's just specifically to your machine after we've gone years with using private addressing. But at one point in time, IPv4 was the same way, as you had to have a specific IP address that was specific to your machine to get out onto the rest of the world. Now it's just that a lot of our networks use private addressing. So this global unicast address is not a new concept at all, but we're revitalizing it with the IPv6. For your machine to communicate to the rest of the world using IPv6, it's going to need a global unicast address. So that global unicast address, although some of it is going to be generated from the machine on your network to do the communication and stuff, some of it must come from an entity outside, something that is going to assign this to you. So let's take a look at what that really looks like. So when you're talking about, let's say you're in a business and you go to an internet service provider and you ask for a block of addresses that you can use, it could actually vary depending on what your provider is and what your needs are, and there's possibly a cost that's involved in it. So there's just going to be a host of different scenarios in here. But generally speaking, what the ISP is going to assign you is they're going to give you the first 3 hextets. They're going to give you the numbers that are going to be right here. They're going to give you an address that is a /48, the first 48 bits. That's going to be assigned to you. Then what you will see is that the next 16 bits, so now we're going to a /64, is you have some leeway to assign to subnets. and you can assign these different addresses to subnets. And then the final 64 bits, so here to the end with 128 bits total, these then would be assigned to the individual interfaces. So you'll see these /48, /64s quite often. Most of our networks, when you're talking about IPv6, they're going to be /64s. So what does that look like from a subnetting standpoint? Well, you're just going to count up. So this is what I said would be the subnet hextet right here, and you just count up 0, 1, 2, 3, 4, and once you get to, once again, it's hexadecimal, so 9, A, B, C, D, E, F, and then it's going to count up to 1, 0. So this is going to count up, and subnetting with IPv6 is much easier than all of the stuff that we have to do for subnetting with IPv4. So what does the range look like for a global unicast address? Well, the range is large, is huge. So it's going to be a 2000:/3. That means that the first 3 bits is going to be 001. And then it'll be either a 0 or 1. So the first bit here is either going to be a 2 or a 3. Those are the 2 possibilities there. So that means our range is going to be anywhere from 2000::, to 3FFF, and then really all F's after that. So, and that gives us a possibility of 2 to the 125th possible combinations. So this gives us how many possible combinations there are with that. So that is a global unicast address. Next type of address we'll talk about is the unique local. When we say local, what we're actually meaning to that is local to your organization. So this could go beyond your subnet, whereas a link local is just your subnet. But with a unique local, that could be your whole organization. It just cannot be routed to the outside. It cannot be routed globally. It cannot go beyond into your internet service provider or into the rest of the world. And the idea behind is that these won't get translated. So if you have a machine that's sensitive and you want it to be able to communicate to the rest of your network, but you don't want it to have access to the outside world, this might be a good case, a good use of a unique local address. All right, what does the range of a unique local address look like? Well, it'd be FC00:7. So the first few bits, or the first 7 bits, is going to be FC or FD. So we see the range is FC00:: to FD, and then all S. And what this does is it gives us a range of 2 to the 121st power. That's the number of possible addresses that we have out of this. Then we have a multicast address, or actually your computer probably has many multicast addresses. And we're going to be getting more in depth into what type of multicast addresses your machine has. But for now, just know that the 2 that we're most concerned with as we're talking about IPv6 is we'll talk about some well-known multicast addresses that we'll be using, and then we'll also talk about solicited node multicast addresses. And it's a very unique thing to IPv6, so we'll get involved with that solicited node multicast address as well. So what does the multicast range look like? Well, that is going to be FF00:/8. So the range of it is anywhere from FF00:: to all F's. And that gives us 2 to the 120th power, which means that there's a lot of different combinations with these multicast addresses. There are a few special addresses that you should know. So one of them is the everything, or the default route. So the default route looks like a : /0. This is similar to a quad 0 that you see with IP version 4. And so it will be anything from : to all Fs. This is the whole range. So this is why I say it's all, or the default route. So a router will say, if you're going to everything, then, or anything, then this is the gateway to do it, or this is the next hop to go out to the rest of the world, or this is the default route. So yes, so this is the all-inclusive way of saying everything. Then we have the unspecified, which is : /128. The unspecified is a range from : to : and so there's only one address. It's all zeros. And so what this is saying is, I don't know. This is essentially a I don't know. So sometimes we'll see it within some of the frames that we send out, or within the packets that we sent out, before it like assigns certain addresses to it. So this is the I don't know, or the unspecified. Then we have the host itself. So the host is : 1/128. So the range is from : 1 to : 1. So just one option here. So this specifies the host itself. This is similar to a 127.0.0.1 or the 127.0.0.0 range, the whole range really. So this specifies the host. So there's the chart as a whole. These are the ones we talked about. And then actually the chart itself is actually a lot bigger. There's a lot more addresses, and it specifies specific ranges. In fact, we'll talk about a couple more in one of our other videos. But just know that these are the basic ones. This gives you the foundation. And in fact, even when like our global Unicast addresses is actually opened up, and there's a few more ranges now. Pretty much it's anything that's not defined by something else is a global Unicast address. Hey, like my videos? Hit that like button. So just know that in general, we've got these ranges in there, and this table actually shows you them all in order. So it's a good visual to see kind of how they all lay out into this address space. So in this video, we talked about the different type of address types: Unicast, Multicast, and Anycast. Then we got into some specific examples and specific reasons for each one of these type of addresses, and where we would use some of those. And then we also talked about some other special addresses. So we talked a lot about different address types and some specific special addresses. So that gives you a good foundation of what the address types are. And then in our further videos, we're going to explore this even further.